So another equation solving technique that we looked at this term is solve by looking inside. So when I take and I look at this square root, inside of it, there's the expression x plus 3. And the question I have is, what does that expression x plus 3 have to equal in order for the square root of it to produce an answer of 6? And the answer is it has to be the number 36. I know this because of some basic number sense. The square root of 36 is the number 6. If you have a hard time figuring out what that number has to be inside, you can just take this value and square it. So when I square 6, I get 36. The point is this x plus 3 must be the number 36. And if it's 36, we're going to get our correct solution. Well, how do I make that x plus 3 equal to 36? Well, I make it 36 by simply saying that x has to be the number 33. You can see I just took away 3 from both sides. So for this equation, x has to be 33. And if you take a look at when I plug it back in, hey, if x is 33 and I add 3 more, well, that gives me the square root of 36. And I know that the square root of 36 is 6. So you can see that our answer does indeed check. The next one is maybe a little bit premature, but we know, and I want to talk about this, that when I take a number and I square it, right, I always get a positive value. So if I look at this equation, I could say, well, let's look inside right here. What number times itself would give me an answer of 9? And it turns out there's not just one, but there's two answers that will do that, right? We know that if I take the number 3 and I square that, that's the same as 3 times 3, which is 9. So that thing inside that I've boxed with the blue could be the number 3. But there's another option. We also know that if I take the number negative 3 and I square that, that's equivalent to a negative 3 times another negative 3. That also gives me 9. Well, since both 3 squared and negative 3 squared both give me 9, it turns out that this thing inside could be two different numbers, right? And we record it like this. Look, the x plus 12 is either the number positive 3 or the x plus 12 is equal to the number negative 3. So this is one of the strange situations this term when um, we could get two different answers. How do I deal with this? Well, to find this value out, I'm just going to subtract 12 from both sides. In this top one, when I take my this equation, I subtract 12 from both sides. I get that x has to be the number negative 9. And down below, when I subtract 12 from both sides, I get x has to be negative 15. So if I was to plug either one of these into this equation, right, I would say, that's fun. There are two values that make this equation true. One of them is when x is 9, and the other one is when x is the number 15. Unfortunately, that looks like I made it into a 4. So two answers that make this correct. And again, this we found by using this technique called looking inside. The last example is a little bit more complicated. Um, we certainly see easier examples of this, but when we see an equation in which we have a variable that's in the exponent, it's called an exponential equation. And the only way that these things, one of the things we have to do is we have to rewrite this so that the bases are the same. So this number 36 is the same thing as 6 to the second power. So the things that I just put in parentheses there is the same as 36. They're equivalent to each other. So this is a valid rewrite of the number 36. So I have here 36 raised to the x power. I didn't change that equation. On the other side, it's 6 to the x plus 9 power. Now, there's one more thing I want to do to rewrite this. I know that if I have a power and I raise it to a higher power, namely right here, you can see I've got this power of 6 to the second, and I'm raising it to a higher power of x, right? When I do that, the shortcut is I can do multiplication. I can multiply the 2 times the x. So I'm going to rewrite this equation one more time as 6 to the power of x plus 9 is equal to 6 to the power of 2x. So here's our final thinking on this particular problem. The only way that these things can truly be equal to each other, because the bases are both the same, the bases are both the number 6, the only way that they can be equal to each other is if this exponent is exactly the same as this exponent. So this is kind of a stretch, but call it looking inside because I'm looking inside the exponents. I'm saying that this exponent must be the same as the other exponent. And if I subtract an x from both sides, I get that 9 is what x has to be. So I believe that if I take 9 and I plug it in for x, this original equation should be true. And I want to verify that. So let's go ahead and do one more check here. So I'm going to take the number 9 and I'm going to store that as x. And I'm going to look at 6 to the power of x plus 9, x plus 9. And I want to compare that number. You see, it's quite large. It's written in scientific notation. This decimal place is going to be moved 14 places this direction. But let's compare that to 36 to the power of not to the power of x also. And you can see when I do it, I get the exact same value, right? So it's true when x is the number 9. Both sides, both this side and the other side, are equal to each other. That's looking inside.